So in this case, we are going to have a continuation still on our straight lines, but the major case about this class is to solve simultaneous equations, all right? To solve simultaneous equations after you have drawn the given lines, all right? You have plotted these, then after you are now asked that solve the simultaneous equations. So I'm going to focus based on the previous method which we referred, which is our table of values method, so that we do not waste time. And like I said, we are going to have an introduction of other methods on how to draw or to plot the straight lines. So this is what we are given. Without wasting your time, let us quickly have this. Using a scale of 2 centimeters to represent 1 unit on each axis, all right? Meaning to say on both axes, draw axis on such that x is greater than or equal to -2 and less than or equal to what? Less than or equal to 4. So that x is taken in within these values, in within -2 to +4, and the y values from -2 to what? To 3. So let us apply the scale first. 2 centimeters. Each 2 centimeters represents what? 1 unit. So from our graph here, this is what we have. So for every 2 centimeters, we are going to represent 1 unit. So on the x, that's 1, 2, 3, 4. All right. So here we are told up to what? Up to +4 from what? -2. So that's from -2. So this is it. All right. And the y values from -2 up to +3. So meaning to say, we're going to have -1, -2, and that is going to be 1. All right, +2, +3. So that is it from -2 up to positive what? Up to +3. That is what you are given. So let us represent the given lines as we have them. The first one, y is equal to 2x minus 3. All right, so let us just have it here. So that's the first one, y is equal to 2x minus 3. So like I said, to sketch this or to draw these lines, we're simply going to use our table values like we had before. Remember, x values being the input and the y values as what? As the output. So this is what you are going to need. All right, let us just insert our x values. So in this case, you consider your x values, where are they taken from? All right, from what? From -2 up to +4. We are going to insert any value of our choice, but also make sure that these values will be in within the interval. So if you take values such as -2, -1, it was going to affect. If you put -2 here, that will be -4 minus 3, which is -7. So you see, guys, we do not have -7. All right, let's see at 0 when x is what? When x is 0 here, it is going to give us what? -3. We have -3 on the y values. We do not have. Our y value is limited to -2. So we are going to look for other values in the positive region, 1, 2, and so on. So let's try 1. So 2 times 1, that is going to be 2 minus 3, which is what? -1. And we have -1. So we can use the value of x when it is 1. All right, what about when x is 2? 2 times 2, that's 4. 4 minus 3, that's 1. We have that. So this one is going to work. So guys, we said when x is 1, y is what? -1. When x is what? When x is 2, y is going to give us what? Positive 1. Let us move on to 3. 2 times 3, that's what? 6. And 6 minus 3 is going to give us what? 3. So that one also can work. We have 3 on the y values. So when x is what? 3, the y value is going to give us what? Is going to give us 3. So that is it. From the given information, those were the best values to work with that we are given in within the interval, all right? In within the given interval from -2 on the y values, that is our output. We do not have -5, -7. We have -2 up to what? Up to +3. So meaning to say the x values that we're going to choose, we're going to be limited from what? From 1 going this side. At least that was going to work. All right, so let us substitute this. We're going to put this, mark these points on the graph, right, from the table of values that we're given. So that's when x is 1, y is what? -1. So that is what we have, 1 versus what? -1. 1 and -1, they meet at this point. You mark the point. So that is 1 and -1 in the y. All right, another one, 2 versus 1, okay? So when x is 2, y is what? Is 1. So where they meet, you mark a point. So that's 2 versus 1. All right, another point is when x is what? 3, y is also 3. So that's when x is 3 here, y is also what? Y is also 3. So where they meet, you mark a point. So that is it, guys. We've got our straight line here. So I'm just gonna reduce here so that I can join these points properly. All right. So joining these points, you are producing the straight line, all right, that we are being asked here. So let us just see here. So like I said, you're supposed to use what? A ruler in joining these lines. You use a ruler and you produce a straight line. So that was going to be something like this. As something, all right, yes, because of these movements now. Okay, let me see if I can adjust this side and this one. So that's something like this, all right? You have got your straight line passing through the given points that you indicated, those 3 points that you indicated on your graph. So they must pass exactly on those points. So this is the first graph, all right? That is the first line that you were given. Let us have its equation. So remember, the equation of this line that we just dealt with, y is equal to what? 2x minus 3, all right? So let us have our line. Okay, so this is y is equal to 2x minus 3. Okay, so you do that for all these lines that you're given. Okay, anyways, let us just quickly have them so that not waste time. So this one, 2y is equal to x plus what? 3. So let's remove these values and start again. Okay, so that is it. So the second one, it was given 2y is equal to what? X plus 3. So since here we have an even number on the y variables, we're going to divide by 2. Whatever that you have, you're going to divide by what? By 2 for the x value that you insert. So since here this is odd, so let us have also, I mean, since this one is prime, let us have a prime number here. So let us actually work with that. All right. So guys, let us just work with that concept of odd. I do not want to change this. So this is gonna be odd and odd, and that is gonna give us what? An even number. So let's use odd numbers since this one is what? Is even. So that is it. So meaning to say, let us try odd numbers, -1. Let's try -1 and see in place of what? In place of x. So if you put -1, it's going to be 2y is equal to, here it's -1, so -1 plus 3. -1 plus 3 is going to give us what? 2. So that's 2 here, then divide by 2 by 2. So y is equal to what? 1. We can see that we have that y is equal to 1. We have this value on the output values, so that is okay. When x is what? We said when x is -1, y is going to give us +1. Okay, so that is what you are actually going to have. Then we move on. Let us have another odd number. So let's pick 1 and see. All right, from there, let us pick 1. When x is what? When x is 1, so it was going to be 2y is equal to 1 plus 3, that is 4. Then divide by 2 by 2. So y is going to give us what? Y is going to give us 2. So when x is 1, y is equal to 2. 1, 2. Then we moved on to another odd number on the x values, which is what? 3. So when x is equal to 3, let's try this. 3 plus 3, that's 6. So 2y is equal to 6 divided by 2 by 2. So y is equal to what? 3. Okay, we are solving an equation here. So when x is 3, y is equal to what? Y is equal to 3. So that is it. You simply work it like that since we have an even number. So let's target what? Odd numbers on that part. So with these points, you mark them just like before. Then you draw a straight line. -1 versus 1. When x is -1, y is 1. You mark the point. Just like that. Okay, another one. 1 versus 2. All right, when x is 1, y is what? 2. That is at this point. So we're going to mark a point here. And another one, it is what? 3 versus 3, of which we marked this point before. When x is 3, y is what? 3. We marked that point here. So that is it. We're just gonna have this point repeated. So let's join and see what we're going to have at the end. So using these 3 points, you join using your ruler. That is, you have got what? You have got your straight line, just like this. Okay. So that's simply how we play around these straight lines. Then do not forget the equation of the what? The line that you just drawn. So this is the line of 2y is equal to x plus what? X plus 3. 2y is equal to x plus 3. So that was it on the second line. Let us quickly have the third one. All right, and finish up. So that is it. Number 3, x plus y is equal to what? 3. So let us take this. X plus y is equal to 3. So using our table of values method, all right, we can see that if we're going to make y the subject, we are not going to divide by any value. So here you can choose any value of x. It is different from that where you can be given a 3, you can be given a 2. So you have to figure out, right, if here I have got an even number, therefore I'm going to focus with, all right, this one, it's odd, and also this one is supposed to be odd so that we can divide by what? So that we can divide by 2 if it was like that. But in this case, we do not have any number here affecting the y value, right? So meaning to say, for whatever value of x that you're going to put here, you're simply going to take it to the other side. So you simply need to pick values of x here that will not affect like the y values which are not on the what? On the Cartesian plane. By just testing, you can just look into values when x is -2, -1, and see which one is going to work, all right? So let's start with, right, our x here is ending up at what? -2. But if we put that -2 here and you take it to the other side, it's going to be what? A positive. So y will be equal to 3 plus 2, which is what? 5. We do not have 5 on our Cartesian plane. It ends up at what? Positive 3. So meaning to say it is limited. That's how you're going to simply test these values up to where you have got values which are in within the what? The interval that you're given. So let's move on from -2. We move on to what? -1 when x is -1. So you take it to the other side, y is equal to 3 plus 1, and that's a 4. We do not have 4, remember, up to what? Up to 3. So meaning to say, this one again is limited when x is -1. Let us move on to 0. When x is equal to 0, y is equal to what? You take 0 there. Is it going to affect? No. So 3 will be equal to what? Y. That's y is equal to 3. Do we have this? Yes, y is equal to 3. The output value that we're given there is on our Cartesian plane. So we can use this point when x is equal to 0, y is what? 3. Let us move on to another one. We just try like that. This one is just easy like that. From 0, we move on to the positive values 1, 2, and so on. So let's try when x is 1. All right, so we're going to take 1 to the other side. It becomes what? A negative. Remember, you're solving for y. So we take this to the other side, it becomes a negative. So y is equal to 2. All right, so this one, we have it. 2 is there on our Cartesian plane, so we can use that when x is 1, y is what? Is 2. All right, let's look for the last value, the last part when x is 2. Take this one to the other side, y is equal to 3 minus 2, so y is equal to 1. And we have 1 on the Cartesian plane, so we can take that point, that is what? 2 versus 1. When x is 2, y is 1. So just like before, mark the points 0, 3. First one, 0, 3. When x is 0, you mark direct at y is what? 3. 0, 3 direct in the y-axis. That's 0, 3. All right, another one, 1, 2. Second one, that's when x is 1, y is 2. We already have that point here. All right, 1, 2. We already have, we marked that one before. Then another one, 2 versus 1. When x is 2, y is 1. We already marked that point. If you take a closer look here, 2, 1. So these points are already there, guys. Simply join these 3 points. You have got your straight line. So you join passing through those points like that. So this is what you're going to have at the end of the day. So that's our straight line. And we write down the equation of the what? Of the line, which in this case we're saying x plus y is equal to 3. So that's it. The equation of the line, x plus y is equal to 3. All right. The last one. Let us have the last line, all right, and solve the simultaneous equations. I'm going to explain there. How do we simply solve simultaneous equations graphically? So it's a graphical method, all right? So number 4, y is equal to what? Minus 2x minus 1. Okay, let's put this one into consideration. Y is equal to minus 2x minus 1. Again here, y is already the subject of the formula, and we're not going to divide by anything. So here there's nothing to look into, say the value of x, just pick any value of x, but compare the output values if they are in within what? The interval from -2 up to +3 for the y values, right? So we're just going to pick randomly from -3 up to +4. All right, so which one that we can use? All right, let's try -2 and see what is happening here when x is -2. All right, -2 times -2, that's +4 minus 1. So that is equal to 3. So y is equal to 3. Yes, we have this y value, which is equal to 3. So that one is going to work. All right, so this one is going to work when x is minus 2. You saw that y is going to be positive 3. All right, let's move on. When x is minus 1, all right, let's try first minus 1. So that is going to be minus 2 times minus 1, which is positive 2, minus 1, which is part of your equation. So yeah, this one is part of the equation, the minus 1. This one is the input value that you are inserting. So minus 2 times that minus 1 gives you a positive 2. So y is going to be equal to 2 minus 1, which is 1. So that's it. When x is minus 1, y is 1. We have this value on our output values. So that is going to work. And let's try when x is what? 0 here. Minus 2 times 0, that's a 0, minus 1. So y is going to be minus 1. We have that one on our output value. So when x is 0, y is what? Minus 1. Just like that, mark the points as before. All right, so let us start minus 2, 3. All right, when x is minus 2, y is 3 there. They're going to meet at that point where they meet. Mark a point, minus 2, 3. Okay, minus 1 versus 1. Okay, I think we marked this one before. Yes, minus 1 and 1. We marked this one before. So we have it. The last one, 0 versus minus 1. So that's 0 versus what? Minus 1. When x is 0, y is minus 1. You mark direct and the y value at what? Negative 1. So using these 3 points, all right, that we just marked, this point and this point and this point, we are going to join and have what? A straight line using our ruler, just like this. All right, so here it simply just shifted a little bit, something like this. So that's how you draw these lines using what? The table of values. So if we have, let's say we had covered other methods according to this series of classes that we are having, you are going to use those methods where they are, where you see like it is easier for you to apply that method, where it is actually easy to apply, then you use the method. But for now, since we referred to the table of values, that's why I was just focusing on what? On the table of values method. But any method can be used to draw a straight line. It's just like we are working with any other topic, there are methods, guys, all right? But here we just focused on a specific method. So that was it, all right? So that's y is equal to what? Minus 2x minus 1, all right? So that's y is equal to minus 2x minus 1. So we have drawn these lines. That was the first part of our question to draw these lines on this Cartesian plane, all right? Then after that, you are being asked now to solve the simultaneous equations which we are given in what? In pairs. The first one is this set that we are given here. All right, so let me explain about simultaneous equations. When you are dealing with straight lines, when you are working with what? Straight lines, and you are solving simultaneous equations, where two lines are drawn, all right, let's say for these two lines that are drawn, y is equal to mx plus c, and another one there, y is equal to mx plus c. If these two lines that we are given are drawn and they do intersect at a certain point, like what is happening here. At the point of intersection, this one, point of what? Intersection, point of intersection, where two straight lines what? Where two straight lines meet. At the point of intersection, it's a point, remember? Point, we're back there. What is a point? We are referring to the x value and the y value. That is the one that builds up a point, the x and the y value. So the x value at the point of intersection And the y value at the point of intersection will be our solutions. The point of intersection is actually our solution because we have what is the x value there at the point of intersection. What is the y value? So the point of intersection is our solution, this one, to the what? To the simultaneous equations. To the simultaneous equations solved what? Graphically. When they are solved graphically, that point of intersection is our solution. What is the x value? The y value, just like that. So here you're given that. Since you've drawn these lines, now they're giving you those lines. 2y plus x, 2y is equal to x plus 3. I mean, this one, 2y is equal to x plus 3. It is exactly this one. We've drawn this. 2y is equal to what? X plus 3. We have it. X plus y is equal to this one. X plus y is equal to 3. We drew these lines. We have these lines. So at the point of intersection of these two lines, that is where we have what? Our solutions. At the point of intersection. So let's have the given lines. 2y plus what? I mean, 2y is equal to x plus 3. All right. 2y is equal to x plus 3. This one. 2y is equal to x plus 3. So let me just try indicate it somewhere. So we're talking about this line. 2y is equal to what? X plus 3. Okay? So that is the first line intersecting with what? X plus y is equal to 3. All right? X plus y is equal to 3. We are talking about this line. We have this line, this one. X plus y is equal to what? 3. This was our line, this one. So where is it that these two lines what meet? Where is that these two lines intersect? They intersect here. This is the point of intersection of these two lines. So at the point of intersection, that is where our solution is. What is the x value? Drop that to the what? Vertical, to the horizontal, where x is what? Where x is 1. And this one, this, you take it horizontally to this part where y is what? Where y is 2. So you're going this horizontally, and you're going down vertically like this to the what? To the x value. All right. So meaning to say that point of intersection, this one, where x is what? 1, y is 2. That's our solution. The point is 1, 2. Yes. But what is the x value? What is the y value? So the x value is 1. The y value is what? 2. You have solved that. So here, x is equal to what? X is equal to 1. Y is equal to 2. Just like that. If you were going to solve these equations in any other way, guys, 2y is equal to x plus 3, x is equal to y plus, x plus y is equal to 3. If you're going to solve this using any method, you're going to obtain same values using matrix method. We talked about matrix method, using elimination method, substitution method, any method that you think of, you obtain same values by solving. That is to prove that the graphical method can also be used in solving of what? Simultaneous equations, just like that. So meaning to say, whenever you're being asked to solve simultaneous equations graphically, you look at the what? Point of intersection. All right, let's focus on the second one, the second pair of equation, item 2. Y plus 2x plus 1 is equal to 0. We do not have something like this, but if you check here, this is the line number 4 here. They just took these values to the other side. Minus 2x is going to give us what? Positive 2x. Minus 1 is going to give us what? Positive 1. This is what happened. So we have this one. We have it. That is the line of what? Y is equal to minus 2x minus 1. They just tried to play around with you guys. If you check here, if you take this to the other side, it's going to be minus 2x. Take this to the other side, it's going to be what? minus 1. So we have that line. That is the line of what? Y is equal to minus 2x minus 1. Y is equal to minus 2x minus 1. This one. All right, this one. Y is equal to minus 2x minus 1. We have this line. We have this line. Okay. So let me try and remove this. Okay. So we have that one. And let's look into the other one. The other one is 2y is equal to x plus 3. 2y is equal to x plus 3, exactly as it is. All right, so we have that line again. 2y is equal to x plus 3, this one. So that is it. Where is it that these two lines meet? At the point of intersection, that is here. What is the x value? So going down, our x value is what? Minus 1. Going this side, the y value is what? The y value is positive 1. So that is our solution. From the point of intersection, minus 1, 1. X is minus 1, y is 1. So that is it here. X, as we said, x is what? Minus 1, and y is what? Y is 1. Just like that. So that is our solution to that. And the last one, 2x minus y is equal to 3. All right, 2x minus y is equal to 3. 2x, 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 2x minus y is equal to 3. All right, here they played around with this one. The first equation here, if you check where y is equal to what? 2x minus 3. The first equation is written as y is equal to 2x minus 3. That is what just happened. If you take this one to the other side and take y to the other side, you see that this is the equation. So that is the equation. This one, y is equal to what? 2x minus 3. All right, y is equal to 2x minus 3. Let's just try and remove this. All right. Y is equal to 2x minus 3. It is this one. 2x minus 3. It is this one. Okay. This one. This line here. So this is the line that we are talking about. They just played around that equation trying to interchange it, but this is the one that we are referring to. Okay. Then another one. It is y is plus 2x plus 1. We talked about this one here before here, this one. Y is equal to 2x. Y plus 2x plus 1 is equal to 0. And we said it is this one of y is equal to what? Minus 2x minus 1. We just take this to the other side. So it's going to give us this. So we have that one. Y is equal to minus 2x minus 1. We talked about this one. Y is equal to minus 2x minus 1, which is this line. So this is the line that we are talking about. So that is it. So we need to solve simultaneously where these two lines meet. They actually meet at this point. So that is for our solutions, we obtain what is the x value from what we have. So here it is the x value in between going like this. So this is in between 0 and what? 0 and 1 in between. So that's 0, 0.5. So you can have it as 0, 0.5 or 1 over 2 as a fraction in between. So that's our x value, 1 over 2 or what? Or 0, 0.5. Then the y value going this way horizontally, you can see that the y value corresponds to what? To minus 2. So that will be your solution to that. So that is our x is what? 1 over 2. And y is what? Y is minus 2. So that is it. That is it here. X is equal to 1 over 2 or what? Or 0, 0.5 as a decimal, all right? And the y value is what? Negative 2. We saw that it was what? Negative 2 here. So that is how you solve simultaneous equations graphically. You just look at the what? At the point of intersection. The point of intersection is actually your solution. What is the x value? What is the y value? So for proof, I want you as an individual to try solve these simultaneous equations separately using any other method of your choice. that you understand using any method of your choice that you understand. I want you to do that, prove, and see you're going to obtain what? Same answers. For clarity's sake. This is for clarity sake. So just use any method. Is it substitution? Is it elimination? Is it elimination by substitution? Is it the matrix method? If you want to strain yourself further using the matrix method, you can do that. It is in your hands. But that is basically how we play around with simultaneous equations. So that is it, guys. Let us do revise. Let us do revise.